Hey guys, so today in this video we're going to be talking about comparing fractions. Now with comparing fractions, one of the things that you're going to need, possibly, not in all situations, but in some, you will need to know about equivalent fractions. So if you need that first, go watch that video first and then come back to this one.
Highly recommended.
So here we have two fractions that have the same numerator. In this case, you don't necessarily need to do equivalent fractions. You can, since the numerators are the same, you can look at your denominators. Now remember, it's not which denominator is bigger, it's whichever denominator is smaller that you have the larger pieces for. And so in that case, that would mean that fraction would be greater than the other fraction that had the larger number as the denominator, which means smaller pieces. So here I drew two rectangles, okay? Because one of the other ways that you can do this is to actually draw it out to see. Now, here's the thing about drawing out fractions to compare. You have to make sure that your wholes are the same. You also have to make sure that your lines are relatively equal, giving equal pieces, okay? So one of the things that you need to do is you need to cut this piece right here. We're going to have this be 5/6, and we're going to have this be 5/10. So this is the 5/6, this is the 5/10. So what we can do is we can take a look at the top one, and we are going to cut this guy into sixths. Now, I can cut this in half first because 6 is a multiple of 2, and there is a video on fractors and multiples, so if you need review on that, if you haven't watched it already, go ahead and watch that as well, but it's not necessary for right now. What I'm going to do is I am going to take and cut both of these in half, because not only is 6 a multiple of 2, but so is 10, okay? So what I'm going to do is I'm going to take this line that I drew, and I'm going to put it about in the middle of each rectangle, okay? So I'm going to move this down just a smidgen to make it as equal as possible. Now remember, it doesn't have to be perfect, but try and make it as close as you can, okay? So here we're going to take a look at sixths. So because I have two sections, I need 3 pieces over here and 3 pieces over here. So as carefully as I can, I'm going to draw thirds over here and thirds over here, okay? And then I'm going to draw tenths. This side is going to be 5, and this side is going to be 5. Okay, so I'm going to draw as best as I can fifths. 1, 2, 3, 4, 5. I'm going to fix this just a little bit because that wasn't exactly what I wanted. So that's close enough. And then I have 1, 2, 3, 4, 5. Now this does not work because this section over here is much bigger than some of the other sections. So if you give me a piece that's much smaller than the piece that Ian's getting, I'm going to be a little upset. So we want to make sure that the pieces are as equal as possible, as he would get upset if I got a bigger piece than he did. So taking a look here, I now have sixths and tenths. So I have 1, 2, 3, 4, 5, 6 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces. You always want to make sure if you're drawing to compare that you are drawing what you need, not anything extra, nothing less either. So here I have 5, 6, so I'm going to be coloring in 1, 2, 3, 4, 5 sixths. And then I would be shading in 5/10. So 1, 2, 3, 4, 5/10. So when you draw it out, it is a lot easier to see which fraction has the largest amount. And for us here, it is 5/6. Okay? The other way that you can look at it without drawing it out is by looking at your numerators, seeing that they are the same, and so looking at your denominators. Whichever one is the smaller number, that means that it is going to be larger pieces. Okay? So a smaller number in your denominator means larger pieces. I'm going to write in the denominator here so as not to confuse us. Okay? Smaller number for your denominator means larger pieces. See how much bigger those pieces are? So if that's a candy bar, I'm getting myself one of these sixths and not one of these tenths, because I want this one. Because you know me and food, I will eat the bigger piece always. So, taking a look at that option, now there is another that we need to look at, and that is if the denominators are the same. Okay? So, if your denominators are the same, that's actually a lot easier than if you had the numerators being the same. I'm just going to get rid of this. There we go. So let's say that I have 2/8 and 5/8. Okay? So if your denominators are the same, it means that there's the same number of pieces. So if this is a large pizza and this is a large pizza, this is pepperoni, this is cheese, there's 2/8 left of the pepperoni, 5/8 left of the cheese. Which pizza has more left over? If your denominators are the same, you just look at your numerators. Whichever number is bigger, that's the bigger fraction. And again, you can draw it out. If you want to use a circle, you can. You can use a rectangle if you want. Depends on whatever it is that you want to do. But if you draw out 8 pieces and you only shade in 2 of them, and then you shade in 5 of them, you're going to see that there is a big difference, okay? So those are your 2 options that you do not need to know about equivalent fractions. Now, there are some times where you do need to know about equivalent fractions, and we're going to take a look at some of those. So here it says a grasshopper weighs about 2/100ths of an ounce. A beetle weighs 8/10ths of an ounce. Which weighs more? Okay, so I'm looking at which weighs more, okay? The grasshopper or the beetle. So here I have 2/100ths and I have 8/10ths. Now, I do not have a numerator that is the same, so I have to look at my denominators. My denominators are not the same here either, so oh my gosh, what are we going to do? Oh, I just said it. We're doing equivalent fractions. So here is where we need to know about equivalent fractions. Being able to take our denominator and make it into a different number. Now, I want to make the tenths into hundredths because I can't take hundredths and make it into tenths because I only have 2/100ths. Now, if I had 20 or 30 or 40, that would work. But 45 I cannot turn into tenths, and 26 I cannot turn into tenths. It would have to be 10, 20, 30, 40, 50, 60, 70, 80, 90 as the numerator in order for me to go down and divide by 10 in order to get to 10 because, well, I'm already telling you partially the answer here, but 10 times 10 is 100. So in order for us to get to 100, I need to take 10 and multiply it by 10. Now, I'm going to be leaving the 2/100 alone. Do not touch it. Don't mess with it. Just leave it be. Okay? Think of it as a sleeping lion. You don't want to go up and tug on his tail because he will take exception to that and he will be very upset. Okay? Or she. Doesn't matter. Both do not like their tails being tugged. So leave it alone. Okay? More work for you if you try and mess with this. Now, what we do to the denominator, we must also do to the numerator. So I'm going to also multiply my numerator by 10. So 10 times 10, we know is 100. So that gives me a denominator that is the same. And then 8 times 10 is 80. So now that our denominators are the same, I just look at my numerators and find the bigger number, which, hello, 80 is much bigger than 2. If you give me 80 M&Ms, I'm going to eat those over just having 2. Of course, the 80 M&Ms might want to be eaten over a couple of days instead of just one. Okay? But that's how you can find which one weighs more, because you have used equivalent fractions. Now, if I just do this, this is not the answer, guys. It says, which weighs more, the grasshopper or the beetle? So the grasshopper is here, and the beetle is here. Grasshopper, beetle. Which one weighs more? The beetle. Yay, the beetle weighs more. Okay. I'm sorry, that wasn't very funny. I apologize. Let's move on to the next one here. It says Myron and Jane are working on the same set of homework problems. Myron has finished 7/9 of the problems, and Jane has finished 2/3 of the problems. Who has finished more of their homework problems? So again, your answer is not just comparing them and saying, ooh, this one's bigger than this one. It says the keyword of who. So I'm looking at a name. I'm looking at either Myron or I am looking at Jane. Okay? So I see 7/9 and 2/3. Now what's important is that we know that they're working on the same set of homework problems. Because what if Myron had fewer problems than Jane? You wouldn't be able to compare those then. You must have an equal amount for both sections in order to compare them. Okay? So if Ian has a large pizza that's a regular pizza and I have a small gluten-free pizza, we cannot compare who ate more of the pizza. Okay? Even if I eat the whole pizza, it will be very difficult to compare with Ian's pizza because his is much bigger than mine is. Okay? So as long as they're working on the same amount of problems, we can compare. Now, we're going to compare Myron, who did 7/9 of the problems, with Jane, who did 2/3 of the problems. Now, I have a problem because I don't have the same numerator and I don't have the same denominator. So I have to make the denominators the same, okay? I can also draw it out as a model, but again, that's not as reliable as using your equivalent fractions. Now, I cannot divide 9 to get to 3 and 7 divided by 3, which is what I would need. Can't do that evenly. So I must multiply to get to 9. So 3 times what gets us to 9? 3. Now what we do to the denominator, we must do to the numerator. Okay? So 7/9, remember, leave that sleeping lion alone. Do not touch him. Leave her alone. Don't get bit by the lion. If you try and mess with this, it's going to make it much more confusing, and you may get the answer wrong. So 3 times 3 is 9, so we have that as our denominator. 2 times 3 is 6, and that is our numerator. Now that the denominators are the same, we just look at our numerators. Which number is bigger, 7 or 8? 7 is more than... I said 7 and 8, didn't I? So sorry. 7 and 6. Okay? Which is bigger, 7 or 6? 7 is bigger than 6 is, because it's more than 6. So, because it's more than 6, 7/9 is more than 6/9, because now we're talking about the same number of pieces in your denominator. Okay? Now here is one for you guys to do and to try. Okay, Jasmine's swimming lesson lasts for 2/3 of an hour. Takes her 1/6 of an hour to do her homework. Will Jasmine spend more time on her homework or at her swimming lesson? I'm going to go back real quick because I actually didn't finish this problem. Remember how we boxed the keyword of who? Yeah, we never did answer that, did we? So, who finished more of their work? Myron or Jane? And in this case, because we are saying 7/9 is more than 6/9, Myron is the one that did more of the homework. Okay? So make sure that we actually answer the question, which is, who does more? And for us, that was Myron. Okay? So here is yours. Okay? Is she going to spend more time on her homework or at her swimming lesson? You guys have to figure that out. Go ahead and pause, and when you're ready, come on back. Alrighty, so here is our answer. Okay? So the swimming lesson lasts for 2/3 of an hour. I had to change that into 6 because this is the one that we don't want to touch. Leave it alone. Really, don't do it. Okay? Don't do it. Just don't even think about it. Leave it alone. Okay? So the 1/6 stayed the same. I had to take the thirds and make them into 6 by multiplying by 2. I did the same to my numerator. If you don't do what you do to the numerator to the denominator, or from the denominator to the numerator, you're not going to get an equivalent fraction. It's not going to equal. Okay? So out of swimming and homework, it took her more time to do swimming. Okay, so she spent more time swimming than she did doing her homework. Okay? So now, here is your stuff that you're going to do. Okay? Now this is the only one you're going to do, but there are 5 of them. You have to decide if each one of these is correct or not. Some of them you must do equivalent fractions for. Some of them you can look at your numerators. Some of them you can look at your denominators. Okay, it just depends upon what's going on. Now, if you are wanting to compare with 1/2, you can do that if something is more than 1/2 or less than 1/2 and one of them equals 1/2, then you can do that. Okay, so go ahead and do this. When you're done, put this in your notebook, put it in your binder, somewhere that you remember to bring it in. Please don't just watch the video. Please do the work as well. It's not going to help you to just watch it and not do any of the work to see if you're getting it right. Okay? So bring it in. Thank you very much. Bye-bye.